This is a demonstration of the Picket Fence Free Fall Lab. And you see the handout, read through it. Read through your objective. Review the materials we need, computer, Vernier computer interface, Logger Pro, Vernier photo gate, Picket fence, clamp or ring stand to secure photo gate. Well, but we have the computer, we have the Vernier computer interface, we have the Logger Pro, we have the photo gate, we have our Picket fence, and we have the stand for the photo gate. You attach the photo gate to the stand, suspending it, and then what we will be doing is we'll be dropping this picket fence or ladder through the photo gate. The photo gate will measure the amount of time in which it was blocked by the shaded area, the amount of time it was unblocked by the transparent area, and this will repeat a few times. Once you have the photo gate hooked up, you'll load up Logger Pro. Logger Pro will automatically populate your table with variables being detected by the photo gate. So let's get to that. Alrighty. Let's open up Logger Pro. Alrighty. Already did a couple runs in here. As you can see, it collected data, collected gate state, open or closed. 1 is open, 0 is closed. It detected the time. From the moment you hit collect, it starts collecting data, and at 6.9 seconds, the gate became blocked. At 6.99 seconds, the gate became open. At 7.14 seconds, the gate became blocked, or vice versa. Anyhow, once you've done the trial, you drop the picket. It'll measure here on the right side the acceleration, and this is the data we want to collect. Or at this point in time, I want to collect this acceleration. So let's collect the data for trial 1. Hit collect. Experiment. We're going to drop the fence through the gate. Ready? And as you can see, it took me 15 seconds from the time I clicked collect to the time I dropped the picket fence through the photo gate, and it collected these values here. I'm going to take these values, I'm going to copy them. You're going to go into Excel. You're going to create a spreadsheet. You could use the spreadsheet in the handout as a template. We've got trial 1, trial 2, trial 3, trial 4, trial 5, trial 6 at the top. And then we got the column of acceleration that will be collected throughout. So what we just ran was trial 1. So let's go to our Logger Pro. Logger Pro. Okay. We want these values. These are acceleration values. Come to our table. I copy and paste off to the side here. And then I take these values and I cut them and I paste them within the table there. Alrighty, at the bottom here, I've got trial average. And what I've done to get this value is I've taken the average of everything in trial 1, every acceleration amount. I've combined them and divided by the amount, which is 6. And then I come up with this average here. I use the Excel formula. I inserted the formula, I inserted the average, and it populated with cells B4 through B9. Alright, this will do the same in respect to trial 2. This cell will do the same in respect to trial 3, and so on and so forth. Repeat these steps 5 more times. Populate this table with data. So, we go back to our Logger Pro. Hit collect. Grab your picket fence. And once again, collect data. Okay. Take that data. Place it in your table. Now, as you can see, after you've populated the table with data, it calculates the average at the bottom if you put your formula in right. I'm going to do this for trials 3, 4, and 5, and 6 off camera, and I'll return after I'm done collecting that data. Alrighty, I'm back, and as you can see, I've collected the data for trials 3, 4, 5, and 6. It's populated, and then we get the overall average on the bottom for each trial. And then this average was taken, as you see, B11 through G11, these cells here, which is the average of the average per trial. And then we'll calculate the percent error. Use your lab to do so. This will be your required value. Your expected value will be the rate of the acceleration of gravity. So experimental value in this case would be 9.78 minus 9.8 meters per second squared divided by 9.8. You multiply that by 100 and you get your percent error. In this case, the percent error calculated is 0.12%.